Projectile motion.
Hello, and welcome to my video. Today I'm going to be talking about projectile motion. But first, what is a projectile? A projectile is basically any object thrown at an angle above a horizontal. For example, Captain America's shield. Let's say Captain America throws his shield at 30 meters per second at an angle of 15 degrees above the horizontal. Let's find the time it takes for his shield to hit the ground and how far away from him it travels. Now, in order to solve these types of problems, we're going to need to first draw a diagram. So up here in the top left, I have drawn a diagram showing Captain America's shield going at 30 meters per second in a parabolic motion at an angle of 15 degrees above the horizontal. Next, we're going to need vector components in order to continue to break down and solve this problem. In order to solve for vector components, we can use the vector magnitude and trig functions. We take the full magnitude times cosine or sine of the angle, and then we solve. Now that we've solved for our vector components, we can begin to solve. But first, we need some equations. These are the four kinematic equations, which we can use to solve any kinematic problem. For the sake of this one, I am only going to be using equations number 1 and equation number 3. Now that we've found our kinematic equations which we are going to use to solve, we have to go over two important key factors, the acceleration in the x direction and the acceleration in the y direction. Since we are going to be ignoring air resistance for the sake of this problem, the acceleration in the x direction is going to be 0. And the acceleration in the y direction is just going to be negative 9.8 meters per second squared, which is acceleration due to gravity. Now we can begin solving for time. The fastest way to solve for the time over the total distance is to first solve for the time halfway, for which we know the velocity at the peak is going to be 0 meters per second. So we can use that for our final velocity and solve. In order to solve for time, you write out all the variables and then you plug it into the equation. I subtracted the initial velocity over to the other side and divided by the acceleration to get the time to the peak, and then I multiplied by 2 to get the full time across the entire distance. We can then use our calculated time value and plug it into the third kinematic equation and solve for delta x. Congratulations! Now you can use these 4 steps to solve any kinematic problem. Thank you so much for watching. Until next time, bye!
The